Alright, so chapter 4 was looking at triangles, especially isosceles triangles. So the two congruent sides of an isosceles triangle are called legs. So I'm going to mark those congruent. Here's a leg, here's a leg. The non-congruent side of an isosceles triangle is called the base. So since this side is not the same length, it's a base. Does not always have to be on the bottom. Two congruent angles are attached to the base. They are opposite your congruent legs. Here's a base angle, here's a base angle. And then the non-congruent angle, this angle would have a different measure up here, is called the vertex angle, made by the legs. And so here's the conjecture. If the figure is an isosceles triangle, then two angles are congruent, and those two angles would be the base angles. Okay, so we learned about 3 different triangle congruent shortcuts. So if we had side, 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 the two triangles would have to have the 3 sides marked congruent. If we had something like side, angle, side, you could have 2 sides marked congruent and the angle has to be sandwiched in between them. Then we could have angle, angle, side. So here's an angle, the side is not sandwiched in between the angles. And then the last one, angle, side, angle. This time the side is sandwiched between those two angles. It's written in the middle, it's in the middle of the angles. Okay, so when you think about congruent triangles, they really have 3 pairs of congruent sides, 3 pairs of congruent angles, for a total of 6 pairs of congruent parts. So we talked about a triangle inequality theorem. For the triangle to exist, any 2 sides added together must be greater than the third side. So we have to test these 3 scenarios. If it's equal to or less than the third side, the triangle does not exist. Then if you think about the sides and the opposite angles, if you're looking for the longest side, it's opposite the biggest angle. The medium side is opposite the medium measure for an angle, and the smallest side is opposite the smallest angle measure. So now we're trying to figure out if it's a acute or a right triangle. So the longest side has to be C. We're using the smaller sides A and B. So here this is just our Pythagorean theorem. So then that would give us a right triangle. If we add up a squared plus b squared and then that's greater than c squared, this actually makes it an acute triangle. And if a squared plus b squared is less than c squared, this really makes it an obtuse triangle. So when we look at this triangle here, we're trying to figure out, does it exist? So to test that, you have to add up the sides. Is 3 plus 5 bigger than 7? Yes. Is 5 plus 7 greater than 3? Yes. Is 7 plus 3 greater than 5? So this is true, so it exists. Now we have to take the small side and the medium side. See how that relates to the big side squared. 3 squared is 9. 5 squared is 25. How does that relate to 49? 36 would be less than 49, so this is obtuse. Okay, after that we have our proof. You will be given these 5 steps to follow. So mark the congruent parts and the givens in the picture for step 1. So they wanted us to prove that AB is congruent to CD, and they told us that segment AB is parallel to segment CD. We were also given in the picture that BC is parallel to AD. So we can find some congruent parts. Well, we'd have angle 1 congruent to angle 3. Since those are alternate interior angles, I'll just abbreviate those. Same with angle 4 being congruent to angle 2. And the last one, since both these sides are shared between the triangles, you could say segment BD is congruent to itself by the same side, or you could say that it's a shared side. So if we want to name the congruent triangles with vertices in the right order, they had triangle ABD. That would match with our triangle CDB. And we knew that because we had 3 things marked congruent. When we just look at one of those triangles, we have angle, side, angle. So that was the shortcut. Then we need to adjust the prove statement. So look back at what we were trying to prove, that AB is congruent to CD. So we know that they're now congruent because the corresponding parts of your congruent triangles are congruent. So your step 5 will always say what you were trying to prove, and this will always be the same by CPC DC. Okay, then we talked about an isosceles triangle. It has specific properties. So the base bisector is this segment EB. It's splitting the base in half. The vertex angle bisector is still this segment EB. It's splitting this vertex angle into 2 congruent angles. The base is that whole segment, KR. Our legs, we have 2 of them, would be segment KE, segment ER. Our vertex would be angle KER. Base angles, I can use just one letter, angle K, angle R. Then we need to name the congruent triangles with vertices in the correct order. So I could say triangle KEB is congruent to triangle REB. The line of symmetry would be segment EB. That segment has a bunch of names. If we were trying to find the measure of angle REB, that would be 67 degrees since that angle was bisected. The measure of angle K we could find by taking 180 minus 90 minus 67 from that smaller triangle, and that would leave us with 23 degrees. The measure of angle KER would be 67 plus 67, or 67 times 2. That would leave us with 134 degrees. The length of segment KE, since these are your opposite angles, your legs are opposite of those. So if one leg was 13, KE is going to be 13 centimeters. And the whole length of segment KR would be 12 plus 12 to give us 24. All right, and that's it for those notes.